Let's start with lecture 2. We are going to talk a bit about manufacturing of a vinyl chloride monomer. Obviously, the whole purpose of this module is to learn how to use Aspen HYSYS. But before touching the software, we need to understand the whole process which we are going to develop using this particular software. So, as I said in the lecture 1, we are going to begin by not begin like we are going to learn the features of Aspen HYSYS by developing a full process flow sheet which on the manufacturing of vinyl chloride monomer. I already wrote a bit about the whole process here, so I will explain it bit very slowly. And why are we learning these things is like okay, Aspen HYSYS is a very user friendly software, that's what I believe. But before touching the software, we need to know what type of process that we are going to develop, and we should know a bit about the reaction stoichiometry, because we are producing some new product. Obviously it comes from some reactant, there will be a lot of bond breakage, and that's why you get a new product, yeah? So we should know the reaction stoichiometry in and out, and we also should know about the reactants, about the quality of the reactants, whether it's pure or whether it's impure. And also you cannot manufacture a product or at at any temperature or pressure, yeah? We should know some particular process conditions. So say like so my reaction happened at that particular temperature using maybe in presence of a catalyst or maybe without the presence of any catalyst, and so on. So these are the information we need. And about the reaction stoichiometry, we should know like okay, in order to produce say like 1 kilomole per hour, 1 kilomole of our product, then we should know how many kilomoles of reactants that we need to add into the reactor. So for this to know that, we need to have the basic idea or the in general the reaction stoichiometry, yeah? So only then we will know how to produce that particular product and how much reactants we need in order to produce say like 1 kilogram of a particular product, yeah? So without knowing this information, there is no point in opening the Aspen HYSYS software. And the whole purpose of this lecture too is to not to explain the theoretical um, aspects behind manufacturing behind manufacturing of vinyl chloride monomer, but you will know like before touching the software, these are the information that I need. So those we are going to cover only those particular topics. Yeah. So let's go bit by bit. It's better to go a bit slow, yeah? And also I recommend you to take a pen and paper, take a note of whatever we are going to cover in this lecture 2, and also we also covered some topics in lecture 1, yeah? So I recommend you to take a pen and paper and take a note, so that way you will know like okay, if I'm going to perform a design project using Aspen HYSYS, these are the information that I need, these are the information that I have to look in the literature and so on, yeah? So let's start. So this vinyl chloride monomer, so normally so this product is normally produced via the, how do we call it as an integrated balance, or if you want we can simply call it as a balanced process. So just to follow the highlighter, the pink highlighter. So whenever I say integrated balance or maybe simply a balanced process, what it means is like I show some small picture here. So you have some process, some reactants flows inside, some products comes out, and we also produce some byproducts. So instead of taking the byproducts out, this byproduct will be fed back into the process. So maybe this byproduct itself is one reactant, yeah? So it will be fed back into the process. So at the end of the day, only the reactant flows in and then the product comes out. So all the intermediate and the byproducts that comes out of the process will be fed back into the reactant. So which means there will be a full closure, or we can say like a tight closure of the material balance. So nothing goes to waste. So whatever the byproducts or the intermediates which is produced uh, during the process, it will be recycled back into the process. So that's the whole idea of the so-called balanced process. Yeah. So let's go to the next step. So this is something that you have to know. So at least without knowing the reaction, at least you know that the the whole process is a tight balanced process. So your process flow sheet will look something like some reactants is going to will go into the process, and then some product, in this case it's a vinyl chloride monomer, and whatever the things that's happening in between will be recycled back into the process. So you get some general idea. So keep this thing in the mind. Let's go to the next point. So during the production of vinyl chloride monomer, so we have three main chemical reaction, or if you want we can call three main chemical steps. In fact it's only two, but the third chemical step comes in order to, what we said earlier, in order to keep the material balance completely closed. So let's see one by one. So the first step is something we call it as a, not we call it, that's the chemical reaction. So direct chlorination of ethylene to 1,2 ethylene dichloride, which is nothing but ethylene dichloride. So I use this simple notation EDC. EDC means ethylene dichloride, and VCM means vinyl chloride monomer. So that's the chemical formula for ethylene dichloride. So I wrote the full chemical reaction here. So that's your ethylene, and you have your Cl2 chlorine, which gives to your ethylene dichloride. So this is something you can call it as an intermediate, and this reaction is highly exothermic reaction. It's going to release a massive amount of energy. Yeah? So minus 218 kilojoules per mole. And the next step is we take this ethylene dichloride, and then we need to pyrolyze, or we can call it as a thermal cracking of ethylene dichloride in order to produce our main product, which is vinyl chloride monomer plus hydrochloric acid. So as I said, this is a pyrolysis. Obviously we need to supply the heat. Normally we conduct this at a very high temperature, so that's why you see this delta H is a positive quantity here, 71 kilojoules per mole. I just highlighted again the formula C2H3Cl, that's your vinyl chloride monomer. So that's the product that we want to manufacture, starting from ethylene. So we went for a direct chlorination of ethylene in order to produce ethylene dichloride, which is an intermediate product. We pyrolyze the intermediate product, ethylene dichloride, in order to get our final product, which is vinyl chloride monomer, and it's going to release a byproduct, which is hydrochloric acid. So keep these things in the mind. So these are like this is like a pure chemistry. Yeah? Like we are not even we are not dealing anything at chemical engineering level. So at the moment we are just looking at a simple reaction stoichiometry. So what we get, what we can see in this is like a let's change the highlighter color. So just to see the green highlighter. So you have some 1 mole of ethylene reacts with 1 mole of chlorine in order to get 1 mole of ethylene dichloride. So keep this stoichiometry in the mind, 1 mole, 1 mole and 1 mole. And then you pyrolyze this 1 mole of your ethylene dichloride to get 1 mole of your product, vinyl chloride monomer, and then 1 mole of your byproduct, which is your hydrochloric acid. And then the first one is highly exothermic. It's going to release a massive amount of energy. 218 kilojoules per mole is a very high amount of energy, and then you're going to supply a lot of energy in the pyrolysis step. Yeah? And then obviously we already got our product, which is C2H3Cl, that's vinyl chloride monomer. Yeah? So if you want, we can just separate vinyl chloride monomer from the HCl, and then we can stay happy. Yeah? So that's what I mentioned here. So if you know how to separate vinyl chloride monomer from the hydrochloric acid, we can separate and then we can stay happy and we can go home, but that's not our objective. So our goal is to maximize the production of a vinyl chloride monomer. So we can make this process a bit more efficient, and we know to do that. So, and also HCl is also an expensive product. So let's use this byproduct through some other reaction. Let's think about some other reaction that allows you to use this byproduct hydrochloric acid to produce more product, in this case which is vinyl chloride monomer. So how to do that? This is simple. We can do that by oxychlorination of ethylene to ethylene dichloride. And how the reaction looks like, I already wrote it for you. So you have 1 mole of ethylene react with 2 moles of your hydrochloric acid plus half a mole of your oxygen, giving rise to your intermediate product, in this case ethylene dichloride plus water. And again, this is also an highly exothermic reaction, and that's your heat of your or enthalpy of your reaction enthalpy. So it's minus 238 kilojoules per mole. Obviously it's a lot of energy. So what we have in this process is like somehow we managed to use that hydrochloric acid, which is an intermediate product from the step 1, which is direct chlorination of your ethylene to ethylene dichloride. So this is something you have to remember. So we can take that HCl, we can make to react with ethylene in presence of some oxygen in order to make the intermediate product ethylene dichloride. Oh, one thing I forgot to mention. So both of these processes, like direct chlorination and also this oxychlorination, but we need is happening in presence of a catalyst. We will come back to that later. So we need a catalyst in order to speed up this reaction. So what we have here now is like we have a process now that allows to make use of the hydrochloric acid produced during the chlorination of ethylene. So we should always think about some of the ideas that allows you to maximize the production. So these are the things that you have to think about when you are going to design a project, like manufacturing of something. So whenever you see some byproduct that comes out of a particular chemical reaction, just to check in the literature, is there any way to use that byproduct or recycle that byproduct in order to make and in order to increase your productivity. So keep these things in the mind. So at the moment we are not going to touch the Aspen HYSYS in this lecture, but we are going to gather all the correct information that we need while we are going to develop the full process flow sheet. So all these tiny little things that we are talking, like, oh, we have 1 mole of this, 1 mole of that, and 1 mole of product, will make sense at the end of this lecture. So, and these are the information that we really need when we need to develop some process flow sheet in the using Aspen HYSYS. So there is no point in touching that software without knowing what we need to do with that software. So that's why we're taking these things a bit slower, and we are also learning this at the correct speed at the moment. So if we combine all this process, which is this direct chlorination followed by pyrolysis, and then the third process, which is oxychlorination of your ethylene. So if we combine all this process, we can combine that. We can call it like, let's integrate all these three reactions. So at the end of the day, an ideal balanced process will look like. So that's your reaction stoichiometry. So it will be like 1 mole of ethylene, half a mole of chlorine, and then quarter mole of oxygen, giving rise to our main product. This is with vinyl chloride monomer plus half mole of water. And if you look at here, follow the pink highlighter now. So the overall reaction is an exothermic reaction. Yeah. So this also includes a pyrolysis step, but but if if you sum up the heat of reaction, the overall reaction is an exothermic reaction, and it releases a lot of energy, around 192.5 kilojoules per mole. Yeah. So, and if you look at the equation, you will see there is no HCl on the product side. So, and that's because, in fact, that's our main objective. Yeah. So in fact, HCl was one of the byproduct of your in the during the pyrolysis step, and we use that byproduct in order to produce more vinyl chloride monomer. Yeah. So that's why you don't see any byproducts in the product stream. So keep these things in the mind. So which means whatever the byproduct that we get, like hydrochloric acid, that will be recycled back in order to get more vinyl chloride monomer, which you see on the right hand side of this equation. So these are simple chemical reactions. These are simple stoichiometric reactions, but at the end of the day it will give you a lot of information that we need for the design project. Yeah. So keep these things in the mind. And then, so this is something we call it as a tightly a balanced process. Yeah. So at the moment this word might look like a buzzword to you, but that's how we call it. So whatever the reactant goes inside, it will be converted into product, and any byproduct and intermediate will be recycled back into the process. Yeah. So something we are going to maintain a completely tightly closed process. And in fact, your process flow sheet should look something like that. Some stream goes inside, some stream comes out, and there will be some lot of recycled streams. So all the byproducts and intermediates will be recycled back into the process. So that's how your process flow sheet will look like. Yeah. And then the next topic. Okay, something I have to mention to you. So I use this word. This is an ideal case. So the reactions which you are seeing here in this box. So this is like an ideal case. We just assume almost near to 100% efficiency. So 1 mole of ethylene give rise to gives 1 mole of vinyl chloride monomer. So this is something like an ideal case. Yeah, but in reality, so you have your hydrocarbon, you have some oxygen that will create some combustion reaction. Who knows, you may even lose your ethylene during this type of reaction. Yeah. So this, in fact, this is one of the limitation of contacting oxygen with any hydrocarbon. Yeah. So but for the moment we are going to assume we are achieving this 100 we are achieving an efficiency which is um, near to 100 percentage. Yeah, following the reaction stoichiometry. So we will come back to that. Even when you are going to develop the process flow sheet using Aspen HYSYS, we can test this. Okay, I put 1 mole of this reactant, and let's see how many moles of product which I'm going to get at the end of the process. So we can check that. We can check that using Aspen HYSYS. Yeah. So anyway, that will be dictated by the information that we are going to add. Let's see. So whenever I say ideal case, which means we are going to assume the efficiency will be equal to the, how to say, like whenever we say ideal case, which mean like just by looking at the reaction stoichiometry, you should be able to know how much product you are going to get. Yeah, obviously this may be far away from the reality. So anyway, we will come back to this later. Just to take a note, the overall chemical reaction is exothermic. This is something that you should have to remember. And then you have to take a note of the reaction stoichiometry. What are the reactants? What are the products in the 3 different steps? And then there are few things that you should remember. Yeah. So we are talking about vinyl chloride monomer production, and if you're going to use Aspen HYSYS, we need some information, like, as I said, like reaction stoichiometry, and also the, how do you call, like how much we need to produce per hour. Here I just added few information here, like say, here I added few more information that you should know about this vinyl chloride monomer